Hello, here we will discuss about skewness and kurtosis. So, or we can say measures of skewness and kurtosis. So, we'll discuss one by one. So, first of all, we need to understand concept of skewness. So, skewness means lack of symmetry. So we try to find out in research our data is skewed or not skewed. And basically, once we study about the probability distribution, discrete probability distribution, and continuous probability distribution, we try to find out our distribution follows is skewed or non-skewed. So there are different methods we'll try to understand here in this video. So now first of all we need to understand skewness. So a distribution is said to be skewed when the mean, median and mode fall at different position in the distribution, and the balance or center of gravity is shifted to one sided or the other, to the left or right. So this is the concept of skewness help us to understand the relationship between three measures like mean, median and mode. So as if we understand these points like mean, median and mode fall at different points, like we have a distribute this line and we can draw this just for understanding. And this is if we are getting mean, median and mode at different points, so this is distributions are skewed. So now let's understand how we'll get it. So here symmetrical distributions of frequency distribution is said to be symmetrical if the frequency are equally distributed on both sides of central value. Central value means mean, and a symmetrical distribution may be either wheel shape or U shape. In symmetrical distribution, the values of mean, median and mode are equal. If we have a data and we are calculating mean, median and mode and we are getting all three values equal, then we can say our distribution is symmetrical. So like this is the normal curve and this is known as the symmetrical distribution. If we have a data and we are going to plot this curve, and if we are finding this value mean, median and mode, all these points, so we can say our distribution is the symmetrical. Now next points, what what is the meaning of skewed distribution? We need to understand here. So a frequency distribution is said to be skewed if the frequency are not equally distributed both the sides of central value. And skewed distribution is two types. First one is positively skewed and second one is negatively skewed. So these two points we need to understand once we have a data or distribution. So see here, first is negatively distribution. So how we'll understand our data follows negative skewed, our distribution is negatively skewed. We need to understand distribution is skewed when the curve is left or negative. So that means we can say mode exceeds mean and median. So this is the curve and we can say once we have a data, we are calculating mean is less than median and median less than mode, then we can say our distribution is negatively skewed, our data is negatively skewed. Now second point is positively skewed. So how we understand our data, our distribution is follows the positively skewed. So if distribution is skewed to right or positive, or we can say mean exists mode and median. So the curve we have like this, and if we have mode less than median and median less than mean, or we can say mean greater than median and median greater than mode, then our data is positively skewed. Now we need to understand tests of skewness. So in order to ascertain whether a distribution is skewed or not, the following test may be applied. Skewness is present if the value of mean, median, and mode do not coincide or does not equal to, and when the data are plotted on graph, they do not give the normal or well-shaped form, that is, when cut along a vertical line through the center, the two halves are not equal, then we can say data or distributions is skewed, and the sum of the positive deviations from the median is not equal to the sum of the negative deviations, then we can say our distribution is skewed, and quartiles are not equidistant from the median, then we can say the data is skewed, and frequency are not equally distributed at points of equal deviation from the mode. So these are the points. So if these are points are available, then we can say our distributions is skewed. Our data is skewed. Now we need to understand with help of the graphical measures of skewness. So measures of skewness help us to know what degree and which direction it is positive or negative. The frequency distribution has departure from symmetry. So positive or negative skewness can be detected graphically as depending on whether the right tail or the left tail is longer, but we don't get idea of the magnitude. So some statistical measures are required to find magnitude of lack of symmetry. So how we'll get it? If we have this curve like positive skewness, so if we have this mean is greater than this median and median is greater than this mode, then we can say the distribution is positively skewed. And if we have this curve like this curve, and if we mean equal to median and equal to mode, then we can say distribution is symmetrical or symmetry or data is symmetrical. And if we have a negative curve like this is known as negative skewed, then we can say if mean value, this is the mean value, is less than median value and median is less than mode, then we can say this is the negative skewed. Now next point, statistical measures of skewness we need to understand. So there are two types of the statistical measures. First, measures in skewness. First one is known as absolute measures of skewness. In absolute measures of skewness, and second one is relative measures of skewness, as I said. And in absolute measures of skewness, we'll calculate like skewness is if we have a mean value minus median, we can find out skewness, and if mean minus mode, we can find out skewness, and if we have a quartiles q1 q2 q3 value is given, with help of quartiles we can calculate skewness. And in relative measures of skewness, there are four measures of skewness in relatives. First one, we can need to find out beta, and this notation is beta, and this is gamma coefficient of skewness, and Carl Pearson coefficient of skewness. Third one is the Bowley's coefficient of skewness, and fourth one is the Cayley's coefficient of skewness. So when we are going to measure the skewness, so we'll measure all these points in absolute as well as relative measures of skewness we need to understand. Now next points, beta and gamma coefficients, how we'll get it. So Carl Pearson defined the following beta and gamma coefficients of skewness based upon the second and third central moments. So beta 1 we can calculate mu 3 square and mu 2 cube. So this is the known as moments. In next slide we'll discuss what are the moments and how we'll get it value. But this formula we need to understand this formula how to get beta 1, and beta 1 measures of skewness does not tell about direction of skewness, it is positive or negative, but it tells us about skewness. And this drawback is removed if we calculate Carl Pearson's gamma coefficient, which is the square root of beta 1. If we have a beta 1 values, then we can find out the gamma 1 values, which is plus minus under root beta 1. So as we know, beta 1 is equal to this, so we can put the value here. So gamma 1 is equal to mu 3 third moment and divided by gamma standard is sigma cube, we can say. And now next slide we'll discuss what is the this moments mu 3 and mu 2 we need to understand. But here we need to remember the formula. If this value is given, we can find out beta 1 coefficient, which gives the measures of skewness, and gamma 1 is also gives the measures of skewness. So now Carl Pearson coefficient of skewness, we need to understand this methods is most frequently used for measuring skewness. The formula for measuring coefficient of skewness given by mean minus mode divided by sigma, where SKP means Carl Pearson coefficient of skewness and sigma represents standard deviation. Normally, the coefficient of skewness always lies between minus 3 to plus 3. Whenever we are calculating the measures of Carl Pearson coefficient of skewness, and if we are getting the value between minus 3 to plus 3, that means our calculation is correct. If we are not getting value between minus 3 to plus 3, that means there are something error. So we need to keep in mind. Now next points, coefficient of skewness, and then we can apply this formula mean minus 3 median minus 2 mean divided by sigma, or same formula we can write 3 mean minus median divided by sigma. So the value of coefficient of skewness is 0 when the distribution is symmetrical, and the value of coefficient of skewness is positive when the distribution is positively skewed, and the value of coefficient of skewness is negative when the distribution is negatively skewed. So these are the conceptual points we need to keep in our mind so that we can have this interpretation once we are analyzing the data. Now, next points we need to understand Bowley's coefficient of skewness. If we have Q1, Q2 and Q3 value is given, then we can calculate measures of skewness with help of this formula. So this is means Bowley's coefficient of skewness. Q1 represents first quartile, Q2 represents second quartile, and Q3 represents third quartile. We can calculate skewness with help of the quartiles, which is known as Bowley's coefficient of skewness. Now next points, if we have median is given, Q3 is given, Q2 is given, so the above formula we can convert like this, and we can find out Bowley's coefficient of skewness. The value that means the value of coefficient is 0, distribution is symmetrical. If greater than 0, it's positively skewed in, and if it is less than 0, negatively skewed. So just way of interpretation we have changed here like previous slide. Now next points we need to understand Keeley's coefficient of skewness. So Keeley's develop another measures of skewness which is based on percentiles and deciles. So as already we are aware what is the percentiles and what is deciles. So the formula for measuring skewness is based on percentile. So we can, if we have P90s, 90th percentile, 50th percentile and 10th percentile, So we can apply this formula, and this is known as the keyless coefficient of skewness, and this is the 90th percentile, 50th percentile, and 10th percentile. If these three values is given, we can find out keyless coefficient of skewness. It's very simple once we have data, and we must be aware about how to calculate P90, P10 if we have group data or ungroup data. This is the important points here. Now next point, keyless coefficient of skewness with help of the deciles. Once we have a decile, then how we'll calculate it? So as we are aware about the percentile formula, so just we are replacing the deciles at place of that. So D1, D5 and D9 is given. Then we can calculate keyless coefficient of skewness, and this is the 9 deciles, 5 decile and 1 decile. These are the important formula we have to be remembered. Then we can find out the skewness. Now next points we need to understand. We have one examples for a distribution called Pearson coefficient of skewness is given 0.64, standard deviation is given 13, mean is given this. So find out mode and median. So here we need to understand how, first of all we need to write down what are the givens in a question. Then we have to understand which formula is applicable here. Then we have to write down this formula, mean minus mode divided by sigma. We can put value already, all these 3 points is given in a question. Then we can find out the mode with help of this equation, which is 50.88. And already we are aware about another formula, which is mode equal to 3 median minus 2 mean. This is the standard formula. We'll take it and we'll put the value here from previous equation, and we can find out the medians with help of simple arithmetic calculation, which is 56.42. So this is the important question, and different type of the question. If we have different type of the data set is given, and we have quartiles are given, percentiles are given, deciles are given, mean are given, medians are given, and standard deviation is given, sum of values is not given. So with help of that formulas we can find out. Now next points we need to understand moments. So moments is very important, as I said in previous, beta coefficient and gamma 1 coefficients. So how we'll get you? So some concept, some specific concept about moments, being researchers and being a statistical analyst, we need to understand what are the moments. So we need to understand basic concept of the moments. So in statistics, moments is used to indicate peculiarities of a frequency distribution. Utility of moments lies in the sense that they indicate different aspects of given distribution. Thus, by using moments, we can measure the central tendency of a series dispersion or variability, skewness, peakedness of the curve, and moments about the arithmetic mean denoted by mu. And the first 4 moments about the central moments are following points we need to understand. So in moments, these are the moments around median. This is the formula for ungrouped data, for group data, and where n will calculate, and moments are arbitrary. This is the ungrouped data and group data. This is little bit mathematical standard equation is given, and we can find out the moments. So details I can tell you in next slide here. So first moment mu1 equal to 0, it represents the mean. And if we are calculating the second moments mu2 gives us the variance. And if we are calculating third moments mu3, it gives us the skewness. And if we are calculating fourth moment, this is the fourth moment, and this is the way we can find out. And mu4 dash, mu3 dash, mu0 dash, in previous slide formulas we can find out, which gives us the kurtosis value. So this is the some basics formula for moments we need to understand. Then we can get the beta coefficient and gamma coefficient values. Now next points, two important constants calculated from mu2, mu3 and mu4, where beta 1, this one we can read as beta 1, and beta 1 used to measure of skewness, and it is calculated with help of this formula mu 3 square and mu 2 cube, and mu 3 is third moments and mu 2 is second moments. So same way here gamma coefficients are beta 2 read as beta 2, and beta 2 used to measure the kurtosis. So always remember beta 1, if we are calculating beta 1 it gives the skewness, and if we are calculating beta 2 it gives us the kurtosis value, and beta 2 we can calculate mu 4 divided by mu 2 square. Mu 4 is the fourth moment and mu 2 is the second moment. So this is the about basic concept, basic in details concept about the measures of skewness and different methods how to calculate the skewness, and basic concept of the movements also we have discussed, and kurtosis. So in details kurtosis we'll discuss in next video. Thank you. Thank you.